Okay, u-substitution in the definite integral. Let's first start with some problems we have seen before. Solve the differential equation. Remember that a differential equation is a derivative. So, given the derivative in this form, first thing we have to do is separate the variables. So we multiply both sides by dx, and then we integrate both sides. Antiderivative of dy would be y. Over here, u is equal to 1 plus x cubed. Du is 3x squared dx. Solving this equation for dx. Alright, so we have 10x squared all over the square root of u times du over 3x squared. X squareds cancel. I'll bring the 10 thirds out front. Now I get u to the negative 1/2 power du. Okay, now integrating, add 1 to the exponent. Dividing by 1/2 is multiplying by 2. We need the plus c because it's an indefinite integral. So our final step, replace u with 1 plus x cubed. So that's a 20. Remember, this was called the general solution to the differential equation. Okay, so now given the differential equation, negative 2 secant of 2x tan of 2x. And we're given whose graph passes through the point 0, negative 1. So separate and integrate. Separate the variables, integrate both sides. Our u substitution, we looked at one of these in class. U is 2x, which makes du 2dx. So we have the antiderivative of negative 2, secant of u, tan of u. Dx is du over 2. The 2's cancel. If the opposite, antiderivative of secant u tangent u is secant of u plus c because it's indefinite. Now the u, replace that to be in terms of x again, plus c, and now we use our initial condition. So y is negative 1 when x is 0. Secant is a reciprocal of cosine. Cosine of 0 is 1. So c is just equal to 0 anyway. So our particular solution is just y equals negative secant of 2x. Alright, let's look at the antiderivative from 0 to 2. X squared plus 1, quantity squared. Now this is not a u substitution because there's no multiplication or division in the integrand. So the only thing that we can do here algebraically is expand the binomial. Square the first term, double the product, square the last term. Using our power rule in each term, x to the 5th over 5 plus 2x cubed over 3 plus x from 0 to 2. Plugging in the upper bound, 32 fifths plus 2 cubed is 8 times 2 is 16 thirds plus 2. Plugging in 0 eliminates the x's. Common denominator of 15. 96 plus 80 plus 30. So this would give us a value of 206 over 15. So remember, just because we're learning u substitution, it doesn't mean every single integral is solved using a u substitution. Alright. Okay, let's look at the integral from 0 to 2 of x over square root of 1 plus 2x squared. So u is equal to 1 plus 2x squared, which makes du 4x dx. Solving for dx, I have x over the square root of u times du over 4x. So now the x's cancel out. We can bring the 1/4 out front. I have u to the negative 1/2 du. Applying the power rule, add 1 to the exponent. Dividing by half is multiplying by 2. No need for the plus c because it's definite. 2 over 4 would reduce to a half. Times 1 plus. So 1 plus 2x squared to the 1/2 power. And we'll evaluate that from 0 to 2. So 1/2, plugging 2 in. 2 squared is 4 times 2 is 8 plus 1. We have the square root of 9 minus, when you plug in 0, this is 0 plus 1 minus the square root of 1. So 3/2 would be our answer. Okay, now let's look at, so using this is, we've made our u substitution in terms of the integrand. So we have 1/4 u to the negative 1/2 du. But our boundaries are still in terms of x, because the bounds came from the original integrand, which were in terms strictly of x. So now a true u substitution, the boundaries would change as well. How do we do that? This equation relates x and u for anything we need, not only the integrand, but on a definite integral, it'll change our boundaries as well. So using this equation, when x is equal to 0, u would be equal to, plug in that value into the equation, and we get u is equal to 1. When x is equal to 2, plugging 2 into the given substitution, we get 9 is our boundary. So if on a multiple choice, if a multiple choice question asks you what would the u substitution for this integral be, this would be the true u substitution. Integrand and boundaries are in terms of u. When you evaluate the definite integral, you can do one of two things. You can do exactly what I just showed you, where we did the u substitution, replaced x, and then substituted in the boundaries. Or if you change everything to be in terms of u, you'll see one thing change. So we still have to integrate, add 1 to the exponent, divide by the new. So we get 1/2. Now, since our boundaries are in terms of u, we don't need to do this substitution of x anymore. If these boundaries are values for u, then we substitute them in directly. So 1/2, oh, I'm just seeing my mistake, 3 minus 1 here, because it wouldn't be the same answer. For those of you that saw it, 3 minus 1 would give me 2 over 2. So my answer would be 1. When I plug in 9 here, I get the square root of 9 again, times the square root of 1. 3 minus 1 is 2. So I get the same answer. Notice here, they're the exact same values as they should be, because once we plug 2 in, whether we plug it in at this step or up here, the equivalent value is 9. So this would be option 2, to change the boundaries. When you're given a question like this on your test or quiz, you can do whatever you want. I just need to see the final answer. It's important that you guys understand what the substitution looks like, though. Alright, let's look at okay, so looking at this, again, not a u substitution. Why? There's no multiplication or division in the integrand. So using our power rule first, antiderivative of cosine is positive sine. So from pi over 3 to pi over 2. Plugging in the upper boundary, pi over 2 squared plus sine of pi over 2 minus, plugging in the lower boundary, two squared is 4 times 2. This gives us pi over 8 plus 1 minus 3 squared is 9 times 2 is 18. Sine of pi over 3, 6, 4, 3 is square root of 3 over 2. So, nasty answer, and we're not going to get a common denominator on this one, although I'm sure if you check it on CapChat, it'll have a common denominator, but I'm happy here. Oh, I keep making mistakes. These should be squared. Sorry. Okay, last example. 0 to 1, x. Definitely use substitution. We're multiplying in the integrand. So u would be our inside function, 1 minus x squared, which makes du negative 2x dx. Solving this equation for dx. So the integral from 0 to 1. So this would be like option number 1. X's cancel. Bring the negative 1/2 out front. Integrating u to the 1/2 power is u to the 3/2 times 2/3. The 2's cancel. I'll bring my negative 1/3 out front. Replacing u with 1 minus x squared to the 3/2 from 0 to 1. Plugging 1 in, 1 minus 1, I get 0. Plugging 0 in, 1 to the 3/2, that's nice and easy, so I get an answer of 1/3. Okay. So option number 2. The u-substitution of the integrand gives us negative 1/2 times the integral of u to the 1/2 du. Now let's change the boundaries. When x equals 0, when I plug 0 into this, u is equal to 1. When x is equal to 1, when I plug 1 in here, I get a boundary of 0. So now look what happens to our boundaries on the u-substitution. They're high to low instead of low to high. So how do we switch that? We take the opposite of the whole thing. The negatives cancel. Integrating u to the 3/2 times 2/3. Now from 0 to 1, 2's still cancel. U to the 3/2 from 0 to 1. Plugging in 1 for u, I get 1. Plugging in 0. So again, we verify the exact same answer. You pick one and be really good at it. Alright, for class tomorrow, I just ask that you do 4 problems. You can check them, all odds, page 307, numbers 75, 77, 79, and 85. Thank you.